Dr. Justin Sturge, Dr. Graeme Stasiuk on the Burnsy Show this morning. Thank you very much for coming in. Who's going to kick us off and explain what's going on? Don't look at each other. I'm going to nominate you, Justin. I'll look at you.
Okay.
Tell us what's going on. Where's your breakthrough? What's it in? And how does it involve a dot?
A dot, right. So the dot's Graham's field. I'm a biologist, a cell biologist by trade. So 3 years ago we received funding from Prostate Cancer UK to develop a new imaging tool that will be able to pick up prostate cancer earlier than we currently can, just by an imaging test. So MRI imaging.
Right.
So currently, prostate cancer, you go to the doctor, you have a digital rectal examination.
I know, my doctor's still not bought me flowers.
And you then go on to a PSA test.
Yeah.
Not very reliable. But it is used, and it's okay, but it's routinely used to monitor the disease.
And some men end up, don't they, with operations they don't need, and other men do need an operation, but the tests don't pick it up. So
exactly.
It's a very grey area, isn't it?
So
and we're talking men's lives here, right?
And also the procedure. So basically, the next stage would then be typically a biopsy, which is quite an invasive procedure.
Yeah.
That's going up through the back passage and then into the prostate to take needles shooting into the prostate.
Collective sound of eyes watering across the Radio Humberside area, but yes.
And what the current impetus really is now, we want to do imaging tests before we go to that unnecessary procedure.
Right.
So what we're doing is developing a tool that might help pick it up a bit earlier and a bit more accurately in those patients at risk of developing sort of more aggressive prostate cancer.
Right. So where are you at, Graeme, then?
So we've just published a paper in Communications Chemistry, which is an open access journal done by Nature Publishing Group.
Right.
And it's to make these little dots. They're nano-sized dots. Now, nano-size, if you think of your ruler, your 30-centimetre ruler, see that millimetre on there? It's 1,000,000 times smaller than a millimetre.
Right, okay.
So we have got a new method to make these nanoparticle dots themselves. The method is to create this platform, these dots, where we can take on and append targeting motifs for the specific prostate cancer switch.
Right, okay. I don't have a degree in chemistry, a master's in chemistry or biology or anything like that. In sort of simple terms, how far off are you from this becoming a practical proposition? Are you still in the theoretical stages, or are you at practical stages?
So we are, at the minute, we have the methodology to make the tool.
Right.
And we're validating the tool in the early stages, and we're just moving on into tissues at the minute. I think practically to see this in man is a good few years down the line.
Is it?
So
is that to do with funding, or is that to do with manpower? Is it, or is this a process you have to go through to prove the science?
This is a process you have to go through to prove the science. So what we've done is the first stage to make these platforms for the tool itself, and then we have to go through further tests to validate through the science, and that takes a number of years to do.
Right.
And then, of course, we look for follow-on funding to make sure that we can translate this into the clinic.
There's no way of speeding up the process if you throw more money and manpower at it, then?
Oh, well, there's always a way of speeding up that process.
I'm not trying to do you two out a job. You can lead it, but I just whether you need more worker-ant scientists or something like that.
I think it will always help to have more worker-ant scientists on this, and more funding will obviously increase the speed at which we make that breakthrough into the clinic itself.
Because this could save lives. This definitely could save lives.
And actually, this study involved collaborations with India, with Leeds. So and physicists at the University of Hull as well, and it was a part of a PhD project. So we had a PhD student, Mitchell Clarke, who's just completed his PhD. He's just writing up his PhD. So this is the first paper out of his PhD. It was all funded by Prostate Cancer UK and the Royal Society partly. So some joint funding there, and it's got us to a long way down the line from where we were 3 years ago. We're now closer and closer to getting this into man.
Right, okay. And so this funding, prostate cancer putting more funding in? Is somebody knocking on the door of the government? I know they're a bit busy with Brexit and things like that, but there must be a door somewhere that people knock on and say, we want millions to do this.
We're knocking on the door. We're putting in an application for more funding to continue with the work, in the coming years. So it's a sort of a process. It's a scientific discovery. It's all about publishing your paper, then they will give you more funding to carry on. And it's like a cycle.
I don't know these things. It's not the world I operate in, but I'm thinking there's obviously something here. Have you any? Is there any doubt in your minds that there isn't something here? If you see what I mean.
No, I think we really cottoned on to something here with this nano platform. We've got some further proofs from Mitchell Clarke's PhD. They'll come out in future publications, and from that we'll get follow-on funding to really get the translational wheel going. So this was the basic science wheel.
Okay. I'm sitting here as a man who, the doctor still not bought me flowers. And, some of my friends have had prostate cancer and things like that. And, this is life-threatening stuff. People lose their lives. We talk about prostate cancer. And I just wonder whether the wheels of all this turn slowly or too slowly. You're in the system.
Yeah.
Do they turn too slowly? What would speed it up?
It is a matter of funding, really. It's a matter of how much money there is. So Prostate Cancer UK, fortunately, have grown and grown over the years. I was first funded by them back in 2007 when they went national, and I've had funding with them ever since then. I've had several projects funded by them. So they have put their faith in what I've discovered to take it forward. Because it's all about translating basic lab science in cells. We just work in cells, in cultures, in the lab. We look for molecular changes. We found a molecular switch that we thought, this is really interesting. We better take this forward. And Graeme and myself joined the University of Hull near enough at the same time. We got together, started chatting over coffee, and all of a sudden we'd come up with this bright idea. So, and we took that forward. And to put it back to Prostate Cancer UK, they said, we'll go with that, and funded us for that project.
I take it there are other teams working on other aspects of prostate cancer that also takes funding, yes?
Yes.
Right, and so you are, to some extent, not quite... Well, you're all working towards the same goal, but they're competing for funds, yes?
Yes, of course, yeah. So Prostate Cancer UK will typically only fund sort of like the universities in London, Oxford, all the top ones, and we managed to bring in the funding to the University of Hull because they believed in the project.
Is there other applications? Sorry to interrupt. Is there other applications for other diseases?
Yeah. So this technology should be it's clearly translatable to other diseases. So once we've worked on translating this for prostate cancer, we'll look at pancreatic cancer, which is also one of those really bad cancers that really have very bad terminal rates.
Yeah, that's from my understanding of it. There's a lady in Scunthorpe who campaigns really vigorously and really well on pancreatic cancer, but it's not many people survive, do they?
No. So if we could translate this tool from prostate to pancreatic, I think that would also be very helpful. I think in the long term, there's a lot of applications in other diseases for these tools that we're developing at the moment.
See, I sit here as a simple man and think, well, why is nobody rushing into your lab and throwing even more money at you and more men and ladies in white coats and saying, crack on, lads and lasses?
Yeah, that's fair. We have actually got other projects running now. It's kicked off in pancreatic cancer, so we're doing We're doing it not with this tool specifically, but it will move into that study. But we've also developed a blood test. So it's a blood test looking at the same molecular change. So we're looking for the release of the same molecule into the blood, and we're looking at that in pancreatic cancer patients now. It's just started in January, so we have funding for that. So we attracted funding for that. Now we just need to... So it's basically... I started off with breast cancer. That's moving forward as well. We've got then prostate cancer. That's sort of a bit behind the breast cancer. And now pancreatic cancer is the next one we're trying to tackle. So we're going in order.
Can we help? Do you need any guinea pigs? Are you at that stage yet?
Not yet at the minute. I think we want to really prove the science really works. And in my mind, it does. But we really want to prove it works first, and then we can move on to that stage.
Okay.
I mean, it has to be safe at the end of the day. It has to be a safe system. It has to be reliable. It has to be well tested in.
You've got to test it, haven't you?
And the other thing Graeme hasn't mentioned is about the toxicity of these things is very low. So you can.
So the original dots that were out about 30 years ago, and you've heard of these quantum dot TVs?
Oh yeah. No.
So there's a company from, I think, South Korea, I won't name it.
Samsung.
That's the one.
Yeah.
There's these quantum dot technology TVs, so they're really bright fluorescent, give you really good colour. The traditional materials are actually quite toxic for human consumption.
Right.
What we've done with these dots is made a completely non-toxic version with the same properties and, in some cases, better properties than the ones in the TV. So we
you
can really
talk to Samsung by any chance?
Not yet, no.
But you're sending them an email.
This is all part of the plan. We have this platform here that could be used as a real good diagnostic tool, and that's really where our focus is. We really want to help the people with prostate cancer.
I mean, the point is, these are what we call super brights. Did we mention that? So they're super bright. They're the brightest quantum dot that's been produced.
Yeah, brightest non-toxic quantum dot.
But if you sell the patent for something that makes everybody's tellies even better, and Samsung snap it up for billions of pounds, then you've got your funding.
Well, but there you go. I'll have a look into that. Thank you very much.
Well, yeah, I'm genuinely, fellas, I'm in awe of this. All the best with it. Thank you very much for coming in. I hope the audience have found that enlightening. I have.
Yeah, I think we're doing a great job in Hull, and we've had a very good PhD student who just finished up, and hopefully we'll get this future funding to continue the work.
Thank you very much, Dr. Justin Sturge, Dr. Graeme Stasiuk.